Hello, my name is Arush Trivedi. I am from BMSC College of Engineering in Bangalore, and today I am going to present my microwave oven project using PICSimLab, which I learned through the Emertxe cohort 14. So let's start. Here is the slide which I will be presenting. The contents are so and so. So, introduction. We are learning what the embedded systems are here in the Emertix internship. And basically, an embedded system is a combination of computer hardware and software designed for specific application or task. It can have multiple examples. These systems are used everywhere these days, like household appliances. As you can see, we have created a microwave oven, automobile systems. In mobile phones, there are specific systems that are classified as embedded, but not the whole mobile system is actually an embedded system. It's more of a all-purpose system and not for a specific task. In healthcare, there are multiple equipments that we use for healthcare and which are embedded systems. Here you can see how an embedded system basically looks like. So the central part of an embedded system is a CPU, that's the processor, and it manipulates all kinds of different peripherals. It takes its data from memories, writes into memories. It takes data from sensors and writes to actuators accordingly. It has multiple other kind of algorithms called software, which is written into the memory, which can be taken by CPU for carrying all kinds of tasks. Then there are human ports, diagnostic ports, and other kind of ports, which are used for safety, testing, and other kinds of procedures. Then microwave oven we have designed was given to us in a specifications which we need to make. So the microwave oven has four modes: microwave mode, grill mode, convection mode, and start mode. So first, the microwave mode, it has to use 900 watts of power, and when we turn on the screen, it will show that 900 watts power. Grill mode is equipped with heating coils that are responsible for grilling, roasting, and toasting food to make it brown and crispy. Convection mode enables the set temperature as required. Maximum cooking time is 60 minutes. And here are the other specifications. Now, I'll tell you what I learned in this Emertech cohort 15. So first is embedded C. Why is C used in embedded systems? In embedded systems, the program code should operate within a fixed memory space to execute the code. C offers a level of control over the hardware. C programming produces efficient and compact code. It produces very reliable code to execute critical tasks. Readability, portability, scalable, and reliability. All these features of C language make them perfect for making them algorithm writing language for embedded systems. And keywords, we have data types. So there are char, which are 1 byte, int, which are 4 bytes, float 4 bytes, and double, which are 8 bytes. Float are specifically for decimal numbers. There are modifiers, qualifiers, and for conditional operations, we have single iteration, if else, if, and switch case, multiple iteration, for, while, and do loops, and jump, which are break, go, and continue, unconditional. Then we have operators. Operators are symbols Operators are symbols that represent operations to be performed on one or more operands. So we have unary operators like plus plus or minus minus, which do a single addition or a single subtraction to whatever it is applied to. Then we have binary operations. These are relational, like inequality operations. Then we have arithmetic operations, plus, minus, into, divide, and mod operators, logical like and, or, and not, bitwise operators, and assignment operators. All these are used for specific tasks which we do in daily needs of embedded systems. So, what are arrays? Arrays are a collection of same data type. What are pointers? Pointers are used to store memory address of other variables, function, or even other pointers. Functions. It is a block of code which only runs when it is called. And what are parameters? They are the variables that are defined during a function declaration. Storage classes in C. So we'll have here used to describe the feature of variable function. These are auto, extern, static, which are local and global, and register. Preprocessor directives. So preprocessor programs provide preprocessor directives that tell compiler to preprocess the source code before compiling. Hash define is used to define a macro. Hash undef used to undefine a macro. Hash include is used to include a header file from the directory. And hash ifdef used to include a section of code if a certain macro is not defined by hash define. Hash if used for the specified condition. Hash else alternate code that executes when hash if fails, and hash end if used to mark the end of hash if, hash if def, and hash if end def. Then, what is a microcontroller? A microcontroller is a compact integrated circuit designed to govern a specific operation in an embedded system. A typical microcontroller includes a processor, memory, and input-output peripherals on a single chip. Other supporting elements: analog to digital converter, digital to analog converter, system bus, serial port. These are all for connectivity and manipulation of data. Things to be noted when choosing microcontroller: performance, price, uh, applications, and availability. So for performance, we have 8-bit, 16-bit, and 32-bit microcontrollers. This right here is an STM32 32-bit microcontroller, but PIC is just a normal 16-bit microcontroller which we are using for the microwave. Applications can be different. For a larger specification of a microcontroller, it can be of a larger calculator purpose, and it is not important that we use such big microcontrollers for easy tasks like a washing machine or a mixer grinder or something like that. Availability, that is also a big thing, because uh, most of the available microcontrollers are cheap, and which are more complex, more powerful microcontrollers. They are more expensive and more rare to find. So, what's a microprocessor? It's a programmable device that takes an input, performs some arithmetic and logical operation over it, and produces the desired output. Computer Central Processing Unit (CPU), built on single integrated IC, is called microprocessor. Microprocessor contains millions of tiny components like transistor, register, and diode that work together. Microprocessor does not have any extra components like memories, or any other peripherals built into it, while microcontrollers do have so. The requirements for the project which we have built today is the mplab-Emertxe IDE, which is the IDE in which we write our code and compile it. The XC8 compiler is used for compiling this code, and PICSimLab is the simulator which we will be using. The microcontroller is PIC16F877A, and the board we'll be using is the PICgenios. Here are all the peripherals that we will be using in that board specifically. So, something about the PIC16 F877A. It's a PIC microcontroller and normally used in the embedded projects. It's developed by Microchip. Properties: it has 40 pins, it has 5 ports. Port A are 6 bits, port A 8 bits, port C 8 bits, port D 8 bits, and port E 3 bits, defined by trace A, trace B, trace C, trace D, and trace E. Port A is used for analog pins, port B is used for digital pins, port C is used for serial communication, and port D are again digital pins. This whole microcontroller is used by uploading hex files into it by a serial programmer. So here is the chip diagram of the PIC microcontroller. You can see size, data bus is 8 bits, instruction set architecture is RISC, that is reduced instruction set architecture. Then here's the internal block diagram of the microcontroller. As you can see, there is the main microprocessor here. Then you can see there are multiple memories and timers and ALUs all around. Okay. Now, as you can see, the peripherals which we are having here are the GPIOs, I2C, the temperature sensor, ADC, RS-232, that is the serial port. So we have LEDs, buzzers, digital keypad, solid state drives, matrix keypads, and the LCD. What? So now about the LEDs. LED is an external device connected to microcontroller port. In PIC16 F877A contains 14 LEDs, which is connected to port D and port B. This is about the PICgenios board. LED array 1 port D RD0 to RD7, LED array 2 port B RB0 to RB7. To turn LED on, LED is equal to 1, and we can use for the basic hex numbers to define all the 8 together. So trace B is used to define the outputs or inputs at the port B. For if you put trace B bit equal to 0, that makes the whole port B as output, and trace B bit 1, that makes the whole port B pin input. And if you want to make a specific pin as output or input, then you can just put trace B1, 0, etc. as 0 or 1, and it will put only the specific pin as a output or input. So here you can see the symbol of LED and the basic circuit and how it is addressed to the port B. Next, we have CLCD, character liquid crystal display. SD44780 is the part number. We have two kinds of options for the CLCD, that is 16x2 or 16x4. That is 16 characters of 2 lines or 16 characters for 4 lines. That has total 16 interface lines. It displays ASCII characters and some special characters. Communication mode for the 4-bit mode has 4 data lines, and 8-bit mode has 8 data lines. RS line. You can see the connection for 4-bit is RD4 to RD7, and 8-bit mode is RD0 to RD7. That means the CLCD on the PICgenios board is actually connected to the port D, and we need to configure it like that. RS line, register select. RS equal to 1 for data and RS equal to 0 for instruction. Here we use 4-bit mode for 2 lines that contains 32 characters. In CLCD, data lines are connected to port D. RS is equal to enable pin are connected to port E. Nibbles, here are some specific data you can see through. Now here's the tactile switch we will use for the keyboard, and it is the like specific component which is needed for making the whole matrix keypad work. So what happens is when it is pressed, it shorts the circuit and thus sends a high or a low according to the active high or active low which we are using. Now, the matrix keypad is just a matrix of tactile switches that are connected in rows and columns. Its applications are everywhere, as you can see in calculators, digital loggers, and telephones, etc. Here is the basic circuit which we will be implementing in the PICgenios board. And here you can see the keypad and LCD connected to the PIC16. Then we have Interrupts. An interrupt is a communication process set up in a microprocessor or microcontroller. Interrupts are handled by interrupt service routine process. An external or internal request MPU to stop the processing. The MPU acknowledges the request, attend to the request, goes back to the processing. So it's a whole routine, or you can say subroutine. Sources of interrupts. External interrupts caused by onboard internal interrupts caused by inside the microcontroller. Next, we have classification of interrupts. There are software interrupts and hardware interrupts. Hardware interrupts can be further uh, divided into maskable and non-maskable. Maskable interrupts are further classified into external and internal interrupts. So next we have timers. Timers come with different resolutions. That is the register width of the timer. It's 8-bit 0 to 6255 and 16-bit 0 to 65535. Uh, a timer can be of different ticks, and a tick is for the 8-bit is 0 to 255. There are 255 ticks. Up count 0 to 255, and down count is 255 to 0. Now, what is a quantum? Quantum is a measure of time which is responsible for tick. So, between each tick is one quantum. So, it depends on the frequency of the quantum we are using. So, one IC time is 200 nanoseconds, and that is a quantum. Scale of the timer is 1 is to 1. Take increment after 1 IC, that is 200 nanoseconds. What is pre-scaling? That is 1 is to 2 or 1 is to 4. Take increment after 2 IC seconds, that is 400. 1 is to 4, that is 4 IC seconds, that is 800 nanoseconds. Post scaling 1 is to 2 is after 2 overflow, go to interrupt shift register. Uh, interrupt interrupt routine. So that is 102.4 microseconds, and 1 is to 4. After 4 overflows, go to ISR, that is 204.8 microseconds. The modes for the timers are as a counter, PWM or pulse generator, or PW or PP measurement. Now I will go on to the simulation of the project. So the project simulation is on PICSimLab. So as you can see here, this is the PICSimLab. Right now I have already loaded the hex file, and the board is the PICgenios. Microcontroller is PIC16F877A. So now I'll reset and show you the working of this. So when we reset, this is the 16x4, we see the powering on. Now we have the main menu. So first we'll start with the microwave. When I click on microwave, it shows power 900 watts. We need to select the timer. So I'll put it as 1 minute, 1 minute, and we can just enter for hash, and it will start. And after the whole working of this, it will stop and buzzer. Now to the next demonstration, I'll just reset this. Now I'll show you the second option, that is grill. I need to set the timer again. I'll just put 20 seconds. Okay, maybe 2 seconds. That's also fine. I'll just put enter, and the 2 1 cooking time above it shows. And then the third option, here we go. Third option, we get to set the temperature. I'll just put 180 degrees Celsius, and the max cook time is up to 60 minutes only. So now I'll enter. Now this is preheating time. So it takes some preheating time, and after that we can even set the time for it. So I'll wait, and then I'll show you how it works. So as you can see, the now timer is over. We can now set the time. I'll set the time to 2 minutes. So that will be, I'll clear it, 200. Okay, clear. That will 0, 0, and 2. That will be 2 minutes, and we'll now put in hash, and that starts the enter. And after it finishes, it will show cooking time over. Next, we have the last mode, that is start. So with the start, it just shows 30 seconds of microwave. We can pause. I just click pause. It doesn't pause. It paused now. And when click start, and it goes start again. Okay, I'll just reset it again. And finally, the demonstration is over. Thank you.